Hello everyone. I'm trying to give you an little bit idea about these problems. Please don't trust on me, like believe on me completely. Check your knowledge. So I make a note before the video because I don't want to waste it your valuable times. That's why I make a notes before the video. Uh, so let's get started. Okay, so first things, my recommendation is for all of you is understand the questions. So now we are trying to understand the questions. So here is the questions. I make a little bit recaps about the questions, so I'm just read out in there. So understanding the questions first, then go for the solutions. Okay, so the first things is there. Let's think about like yourselves, uh, imagine that you have five friends named that A, B, C, and D. Okay, they need to share three rooms. One rooms can maximum, in a maximum we can hold two peoples. Okay, so it makes sense that uh, that you have five friends and three rooms, and one room can each room, I mean that each rooms can hold maximum two peoples. So you have to also that you must have to share the rooms with your other friends. So here from our questions we understand that they give a preference. Your friends have a preference, is actually like he actually which one he choose for staying with them, or likes want to share rooms with whom. Okay, so the friend preferences are like A want to share with B or E, B want to A or C want to B, D want to share his room by C or E want to share his room D or A. But here is a question about this 2 1, like if I take a first example, like A want to share rooms with B or E. So A, B, and E cannot live together. There is your A friend choose between this 2 1, between this 2 1 2 1 is 1, like A can stay with B, A maybe can stay with E. He cannot stay with all together. It's like 3 person cannot stay in the rooms. Okay, share in the rooms. So you have to choose which one he want to share his room. Okay, so we can understand that at the like the same preference for the others persons. So so each person have a preference that which person he want to share their rooms with. Okay, so we can understand the questions, I think so. And now our first steps will be coming. But here is a questions come that can we can can we like accommodate all the friend based on their preference, or like can we make sure that each friend is assigned to one rooms and that no room has more than two friends? How we can do that? Okay, so first of all we have to like we want to assign a value, like we can represent it is friend accommodations in a rooms with a variables, like think we are assigning this value, like here is a1 a2 is a possibility. So let's think about is this one. Let's think your a friend can choose room 1, your a friend can choose room 2, your a friend can choose room 3. So this after the after the a uh, in there is notations of 2 3 subscript in there is represent the room numbers. Your a friend can choose from this room the one. Okay, it is similar for the your other friends, like there is a possibility for the likes each one can choose 3, each one can choose 3 to 5 on 5. So we have 15 possibilities. I mean that your friends have a 15 possibilities, like like if we consider like if one person have a three choice, like they can choose their rooms from the three rooms. Okay, now we need actually we need to convert each friend preference in a logical statement. It makes sense, right? It makes sense. So because we are working with a logical statement, and we want to solve it like in a logic system, so we have to absolutely convert our preference, convert our friend preference to the logical statement. So if if A is in room 1, sorry, if A is in room 1, then either B or E must also be room 1. That means that if your A friends in room 1, there is your A friend is choose the two persons, I mean that if either B or E can stay with her. So maybe B can stay with your A friend, or maybe E can stay with your A friends. Okay, so at the same thing is going for this, at the same thing is going for the your other friends, like your B, C, D, and E. If A in room 1, then B1 is B in room 1, and E1 is E in room 3. Must be true. What does this statement is mean in there? So your A friend can stay in room 1, your B friend can stay in room 1, your E friend can also stay in room 1, but the preference of your friend is themselves which rooms as a point they can choose. It's like someone is choosing the one rooms for themselves, they have to choose their friends also with themselves. I mean that it's a little bit complicated, so feel complicated, but in an easy way, if I think that every rooms have a possibility to choose themselves, like if your A friend choose room 1, she maybe not choose room 2 or room 3. Okay, these two rooms will be empty. So these two rooms, let's say your B friend choose room 2, he cannot choose room 1 and 3. Okay, it's like that. Okay, I think you can understand that, and your every friend must be exactly in on rooms. This I actually want to tell you before, that your your A friend choose room 1, your B friend choose room 2, your C friend choose room 3. That means your is friend is friend is staying separately in 3 rooms. Okay, so it can be in room 1 to 3, not more. I told you before that. So we come to the logical part. Okay, so it can be rooms A, room number 1, 2, and 3. It can be in room. Okay, but he cannot leave more than one time. What does it mean? I means that he cannot at once. He cannot leave 1, 2, 3 rooms. He have to choose just one room, not 3. Okay, you have to choose like 1 rooms. Okay, so it is for every friend is true. It's like that. So logically we can say that it can be your A friend can be staying in a room 1 or room 2 or 3. Okay, so A is in one of the rooms, like your friend have to like that. So the thing is about your F friend have to choose a 1 rooms, which room he want to stay with someone maybe. Okay, so additionally we have to ensure that, and the beside of that, ensure that not more all of this can be true at the same time. What does it mean in there is like I again and again, like I give you the explanations before the topic is coming, so I'm sorry. So that there is a not any possibilities to one person can stay in the two rooms at once. Okay, so logically we can say that the A cannot live in, if A1, let's say like A1 is choose A3 rooms, he cannot live in A1 and A2 rooms. Okay, it cannot be room A1 or A2. because he already chose because he already chose because he already chose the A3, so he have no possibility to stay in A1 and A2. Okay, so and the since the east rooms can hold only two friends, and east room will be the capacity. So this is about the room capacity. This is about the room capacity, so each room has and you can, like, your friends will stay only two. I mean that one in all rooms can live only two friends. So maybe the capacity of the rooms will be two maximum, or like less than or equals two. Okay, so if we again take the example of A1 or like room 1, let's take a example of two. Logically we can say that, like, this is statement, these expressions, but this is what is telling us about that. I will explain it right now. So A1, B1, C1, D1, E1, that means in a room 1 there is a possibility to live or stay everyone's from your A friend to E friend, but in there is maximum persons will be lives like 2 1. Like if A1 and B1 staying in the room 1, maybe the CDE will be not staying in the room 1, like the others. Like the it is similarly true for the other persons, like your other friends. Okay, so what does it mean? There is the we are adding up many A B C D E. I mean that this is this is your friends. Okay, we can adding up A B C D E are in a room 1. It should not be exist 2. So there is a little bit clear idea about that. Is in on rooms you have a possibility to living a combinations of your friends, but it should not be existed too, because there in your rooms have only a capacity for the 2 persons. Okay, so maybe we get our explanations in a writing form. Now we want to check our idea or our knowledge through our computer or machines. Is that we using like SMT leave is like this kind of solutions. The problem set solver. Okay, set solver is it. Okay, so again I recapping the things is first of all you have to represent your friends and rooms with a simple true or false statement like that. So you have to say the rules of the preference, who wants to share with whom, then ensure each friend is assigned to the one room. I mean that you have to ensure that every one persons will stay in the one rooms. It's like that. Check the room capacity to make sure that no room is overbooked. It's like that. So then now we are using our set solver to check that is it real or not, it is a possible or not, it is a consistent or not. It's like that. Okay, in the first thing we have to declare the variables for each of your friends and each of rules. So your friend was A, B, C, D, E. Okay, there is your sorry, I'm actually sorry. This is a screenshot, sorry. Oh my god. Okay, this is your friend in there. Your 5 friends, they have a capacity. I mean that, sorry. In there, they have a capacity for like 3. Every persons have a 3 choice. Like, they can choose from the 3 rooms. So they can choose 1, 2, 3. Like we are just declared the value. We declare the value for the friend and his rooms. A can leave 1, 2, 3. B can leave 1, 2, 3 rooms, or 3 rooms, 1, 2, 3 rooms, 3 number rooms. I mean that there is a for everyone's have a 3 rooms, room number 1, room number 2, room number 3. So they have a possibilities to choose any rooms from the hotel. Okay, but you have to choose it from these 3, not other than that. Okay. Okay, we declaring the value, and this value, when we declare this value, its value would be true or it would be false. If this value is true, if value is true for the sum for your friends, someone's, this friend will be in that room. If the false, the friends will be not in that room. Okay, and then the thing is we check our conditions. Comes to the conditions, I mean that conditions for likes, the first thing is every rooms have the capacity to hold it to ones, we know that, but in there we have to check that and ensure, we have to ensure that in every rooms have a different kind of friends. So I mean that in room A in room A we have to, we in room A or in room A, I mean that, sorry, in room number 1, maybe stay your A friend, B friend or C friend, but they cannot live together. Ensure that your one rooms have your one friends, one rooms have at least your one friends, so we check in there. So asserting these rooms, A must be in on rooms. So is there rooms is or operations or A1s, A2 or A3. Your A friends would be room number 1 or room number 2 or 3. Within these 3 rooms he can be one, he can be staying in one. So A must have to be in room 1, let's say, or room 3 or room 2. It is same things go for the room, it is same for the your B friend, it is same for the your C friend, D friend and E friends. So they have to choose at least one rules for themselves. So this would be the like conditions. Okay, so we have to ensure that one friend choose a one room at least. It's like that. Then we have to consider that a room capacity, this is the room capacity, this is a capacity about that. Okay, so here is like, let's talk about the first one, we will be get a good knowledge from the next rest of the things. Okay, let's think that how many friends actually in room 1 have a combinations, how many friends or count, or how many friends in your room 1 can stay. We can do it by this expression, assert not less than 2 in the last things you see there's in there. In room 1 can stay these combinations I give you before, is that these combinations, but in there within these signs and this number is mean that in there cannot be stays more than two persons. It may be your A1 friend, A friend or B friend, then rest of the is cancel out. Maybe your C friend or D friend, rest of the cancel out, but not more than 2 persons. Okay, so here is meaning that count how many friends in room 1, adding by the booleans variables is like that. So you can get that. It's like the here is the constraint is this one is mean that in every rooms have a capacity the maximum 2 persons. Okay, so we make a conditions between that. Okay, we using the constraint to like that. So cannot be exist greater than 2. Okay, so we give the conditions in room for the room 2 is the same, for the room 2 is the same. Yeah, they can stay your maximum your C friend or different, let's say D2 E friends or A2 A friends, but there is a thing is like in one rooms they cannot lives more than 2 persons. Okay, so at the last part we have to check our set and get the models. If you want to get more details about that your code, you can do it, but it's ultimately you have to check your set. If your result would be set, it is constraint. If your result would be unset, it would be unconsistent. I mean that if your set is like your result is set is a consistent, or unset is like inconsistent. It's like that. So we have to find the, it was our questions like check whether this requirement are consistent or not. So we have to find our statement is consistent or not. So let's dive into the our code. I make this code before for for like reducing the spending time on the lecture during this video. Sorry, again and again I told you about the lectures, sorry. So I write this code before, just we are checking how it's actually working on the PC or like in our machines, uh, just for see the result. Okay, okay, just see the result code. This was our uh, last code which we using for checking our set. If our set checking is like uh, true, is like true, I mean that if the result is set, these functions or like this questions answer will be consistent. And if our code is giving the result of unset, our answer will be uh, our answer will be like unset, means that inconsistent. So let's try what is happening in there. So I can give you the more details note beside that and comment adding after that, so no problems. This will be good for you for your better understanding, so you can understand the code uh, line by line. So I'm just get now for checking the set. Don't get models because it will helpful for the later. I will see. I will give you a advanced knowledge about that in the later. Okay, just check the set. I'm saving this file. Okay, here running code. Okay, this is set because we completely satisfy the code. We completely satisfy our set. Okay, set solving. Okay, so that means the result is set. That's why the question was about the consistent or inconsistent. So our answer is consistent. And then if we want to get more details, we can check our get model. Get model. Okay, then we save it, then run it again. We can get an idea what is happening in declarations of variables, which variable is true, which variable is false. We can understand from there. Okay, okay, we get that. There you can, if I give you a like a1 is true, sorry, a2 is true, b3 is false, uh, d1 c1 is false, is like that. With variables is false in there, you can see in a more details way. So it is fine for understanding this code, but I don't like, I actually so much lazy person, that's why I'm just checking it is sad or not. Is if it's sad it is consistent, or if it's not sad it will be not consistent. So it's like that. Okay, have a good day. I will be happy if you understand the lectures. If you have any questions, it's like somewhere you feel doubt or you have so many questions, you can feel free. You can DM me. You can feel free anywhere in. You can DM me like that. That's it. Thank you, everyone.